Projectile motion. So before we start looking at the equation here that has different variables, I just want to remind you that when we were starting off this unit, we talked about finding the axis of symmetry. We talked about parabolas and how they're going to be curved going through the x-axis and whatnot. It could go up or down. We are going to take that and apply it to real life scenarios. So we continue to talk about the equation that's in standard form, ax squared plus b of x plus c. And we learned how to find the axis of symmetry and used x to help us with the vertex with the equation negative b all over 2a. Now today, this problem has different variables, and that is okay. We're still going to be able to use this concept here. A soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h is equal to negative 16t squared plus 90t gives the height, h, of the ball after t seconds. So instead of us having the variable x, we just have the variable t. So know that our negative 16 is really our a value. So a is equal to like negative 16. And that means our b value is equal to 90. And there is no c value here. Find the maximum height of the ball. So if you were thinking about kicking something, the maximum height would end up being really that vertex. That's what we're looking for here. So I know I expressed x is equal to negative b all over 2a, but in this case, it's really us finding t, and we're using the same equation, negative b over 2a. So t has a negative, and we have to put a 90 there because it is a negative, and then whatever our b value was, all over 2 times negative 16. This becomes negative 90 all over negative 32. And I know a negative divided by a negative will give me a positive. This is equal to 2 and 81/100ths. So right now we're starting to find like the x value for our axis of symmetry. But remember, if we're trying to find like, okay, here's the ball that's being kicked, with the vertex here, we need both points. So we're going to need, like, what is 2.81? It's time here. And then what is our y value here? Well, that's height. So we're still trying to figure out the height. That means we're going to substitute 2 and 81/100ths into this equation. So h is equal to negative 16 times 2.81 squared plus 90 times 2.81. So we're using substitution to find h. When you end up squaring this and multiplying everything, you do get an answer of the height being equal to 126 and 56/100ths feet. The main question here says find the maximum height. So while the vertex itself would be at the point 2 and 81/100ths and then 126 and 56/100ths feet, they only want the answer about the feet. So, the height. So that's your answer that's here in feet. All right, next question, part B, how many seconds will it take for the ball to reach the ground? So if the ball is reaching the ground, you have to think, all right, well, what does that mean about the height? So if the ball's at the ground, the height is 0 feet. So I need to set my equation equal to 0. This negative 16t squared plus 90t is equal to 0. And now I have to look at my negative 16 and my 90 and see if there's a factor I could pull out. The greatest factor I end up working with, it's going to be a 2. I also know that I have t in both of them, so I can take out a t. We end up with negative 2t. So negative 2 times 8 t will give me a negative 16, and then a negative times a negative will give me a positive, and this is negative 45, but I don't need a t this time. And I'm going to set this equal to 0. Since this is factored out, I don't set this equal to 0 and solve for it. However, I do solve for t here. 8t minus 45 is equal to 0. 8t is equal to 45. When I divide 45 by 8, I won't get a whole number. I get 5 and 625 thousandths seconds. So almost 6 seconds. So if you're kicking that ball, it goes in the air, then that's how long it takes before it hits the ground. My answers are right here.